Hello, we are interested in building the linked list data structure. Let's start. So first thing we need to do is we need to create the node, and I'm going to call it node, and it's going to contain two things: an int lm. So it's an element, it's a linked list of integers. That's what we'll make first. And next is class node star next. This is class node. Good. What is the next thing we need to do? We need to then create the class linked list, and it's going to contain the head pointer. And what is the head pointer? It's of type class node star head. Okay. The next thing we need to provide is we need to provide the functions. We need to define the functions which we are interested in. What are the functions we want? We had said we wanted void addFront. So this function is going to add an element to the front of the list. Right. Next is void removeFront. What else? The next thing we need to do is length, len, and finally we wanted search. Okay. So search is going to return whether this number is present in the list or not. Okay, good. Right, now let me just write these functions. So void add. So a few things, there are a few things we have to do. We have to find. We didn't say which of these are private members and which of them are public members. That is remaining. We'll do that. But before that, let me just write all the functions first. All the function implementations. That's what I'm interested in right now. And I'm going to first write the addFront function. Okay, so I'm interested in adding this integer to the front of the list. Right, so let me first take a temp variable, and I'm going to add it to, I'm going to store it in head. Right, the next thing I am interested in is I am going to have head is equal to, so I'm interested in creating a new node, right? So it's a new node, and I'm going to set node of lm is equal to x. And what about node this head next? That's equal to temp, right? We have our addFront function, removeFront function. So I want to remove them. So I'm going to write class, this is head, right? Now, okay, so first thing I'm going to say is the following: if head is equal to null, clearly I can just return, because there's nothing else to be done, because there's nothing else to be removed, right? Now on the other hand, if class is not equal to null, okay, I have taken the head pointer into temp. Now I just have to replace head with the next. So it's a next pointer which I have to replace with. Good. And we have to do one thing. Since we have to remove them, we have to now delete them. I'll also do the following. This is for we need to also have a function to let's say this is just a function for our use. So I'm going to write a print function which is going to print all the elements in the linked list. Okay, so I'm going to printf %t comma next. Right, sorry, okay, wrong. But how am I going to print? I need to go through the entire list, right? So I'm going to write class node star iter is equal to head, and I'm going to write while iter not equal to null. I'm going to say printf right. I just print the element, and I'm going to write iter is equal to iter next. Good. That's printing. Okay, I think we'll let the len and search functions remain, and in where we'll just try to write the main function. The main function is going to be int main, and it's going to be it's going to create. So let me just add a. Okay, first I'm going to create the link list. LL. Okay, and I'm just going to add something. I'm going to add friend 10. So next I'm going to add friend 20. Next I'm going to add friend 3. Okay, and finally I'm going to just print. Right. Sorry, I'm going to print. Good. And after that, I will have a 3 remove. That's also good. But I need to do one thing. I didn't set head to be null, so I need a constructor for that. I need to say that the head is null by first creating a constructor. So I'm going to first create the constructor here. It's going to set things to null. I also need a destructor. Why do I need a destructor? Okay, so the constructor should not have this void, and I need a destructor. Why do I need a destructor? I need a destructor because when I leave this class, I have to delete all the nodes which I created in the addFront function. I need to do that, right? Because if I just leave without deleting it, it's basically against the rule. Our rule was that whatever I allocate, I have to remove. So I have to do that. So now to do that, I'm going to do the following. I'm going to again copy this print thing. I'm going to iterate through all the. I'm going to iterate through this the linked list, and I'm going to remove. Keep on deleting. Okay. Just I have to first copy it. Okay. It's fine to even. I'm going to iterate and delete. It seems good. I go through each of the node and I delete everything. Yeah. While it is not equal to null, I create a node, I copy the head to it, and yeah. So and then it is going to be my next item, and iterate it. Good. So if I start off with null, I don't enter here. If I don't start off with null, iter becomes head, and head becomes the next. Okay, good. I never delete a null. That's what I wanted to check. That's good. Now this seems to be working and it should work. So let me just compile and see and run it and see if things are getting printed. Right. So there are many errors. What is the first error? Ah. Something about removeFront. This is linked list, not right. removeFront does not have an int. Why did I do that? What? Maybe I didn't say it. removeFront. Ah, why is removeFront having a okay. Now that's the main thing. I never made public and private. Okay. Now for the time being, let's just make this public. I want it public. Why is it right now I want it public? Because I'm using the node iter. Right? So I'm using the node, I'm going to use lm next etc. And so that's why in the linked list class, I'm in the linked list class, I am using the contents of this node class lm next etc, which is why since I'm using it outside this node class, I have to make these things public. And but that's not a good strategy. We will fix that. Right now let it be public. Okay, so things work right now. So yeah, so it's 3 20 10. Is that the way it should come? Right, because addFront 3 should come in front, 20 comes behind, and 10 comes behind. 3 20 10. So it's working correctly. Okay, now let's do the following. I want to make this private first. Okay, first of all, so if that is private, I can't do this iter and everything, right? I can't use this, I can't do this. All these things are not possible. So this, I can't do this. So what is there to be done? So in that case, what I'm going to do is that I'm going to make this node to be a friend of linked list. So let me see, check this. This one. I have to write friend class linked list. So it's basically saying linked list is a friend of node, and therefore a friend can use it. That's the main idea. Okay. So even though it's private, the linked list class is a friend of me, and therefore I'm giving it permission to access my private data. That's kind of the logic. And so now it should work as before. Yeah, it's working as before. Good. What is the next thing I have to do? Let's make this better. Okay, I'm going to make a constructor, right? So this should have a constructor. Basically, it's going to have a constructor which is going to say, it's going to take in x and class node star next, and it's going to set lm is equal to x and next is equal to next. Okay, and I can have another constructor here which is going to just that, and I'm going to just set this, and I'm going to set, and finally one more constructor which is a just no input parameters, and it's going to just set. That's it. Right, now once we have that, I can just use the following. I can just write head is equal to new node. What should I pass? X comma head, right? This is my function for addFront. So while head is not equal to null, I can just use the removeFront function, right? So my aim right now is to simplify the entire code to make it as succinct as possible. So while head is not equal to null, I'm just going to keep on removing front, and the remove front takes care of this fact. Good. Now about next thing is length, and for length, I'm going to do the following. I'm going to have a length variable here, which is going to be set to 0 in the beginning, and it's going to increment every time I add a node, and it's going to decrement every time I delete a node. Now we know what has to be returned when we do length. Okay. Now next thing is search. I'm going to search for an integer x. Now if I'm going to search for an integer x, the way to do it is the following. I'm going to write, basically I have to iterate through all the the node, and so therefore I just copied this iter code we have already written, and it's going to check. It's going to say here, okay, so this is if iter is not equal to none. Sorry. If this is x and then I return 1, so let it be, and sorry, I messed up. Let's fix that. Good. So if that element is equal to x, I return 1, and if I come out of this while loop, I return 0. So all I do is I just go through the while loop, and one by one I check whether that element is equal to x. If I find something equal to x, I return 1. Otherwise, I just return 0. That's it. Fine. What else? What is another function we would want is int the ith element, right? So what is a good name? Let's just call it element and the index, right? So I'm going to call index. Now I want the ith element. So if that is the case, I'm going to go through. I have to copy this to both of these functions here because I never. The index. What is the index going to be? How I do that? I have to again copy this code through our linked list, and I just do what is it I have to do? I have to check. So I have to have some x. Wait, I is equal to 0, right? I am going to do the following. So if I is equal to index. Okay, so the index starts from 0 first of all. That's the first thing we need to understand. Then we return 1 saying that we return that element. Then I do iter is equal to iter next. Then I do I plus plus. Actually, I don't want this I. Let's make this simpler. I'm going to just check whether index is equal to 0. So first of all, okay, I need one check. If index is greater than len, what is it? Return. Let's say 0 is kind of saying, so okay, so that's one catch here. It's going to return 0 to say there's an error, right? Now if index equal to 0, I'm going to return now I'm going to just do index minus minus. Otherwise again I'm going to return 0. Okay, let me just compile and see whether things are fine. So this something is wrong because len was not defined. It has to be length. Okay, good. That's good. So I can check for an element. Let's do some of that. I need to see if ll dot search of, let's say 20, this is true, then I'm going to say printf yes, it is there. It's there in the list /n. Let me make a /n here also, and okay. We will do that again. We will do one more thing. And this is LL is searching for 30, and I'm going to say no. It is not there in the list. That's also good. Next thing which I can do is I want to check for printf the second element. Okay, what should be the second element? Second element should be 20. So I'm going to element 2. Okay, so it starts from 0. So 1. I'm interested in 1. First element. So 0 is 3, 1 is 20. Right. So it's going to print that, and then I'm going to do a remove, and then I'm going to try this again. Okay, so 30 gets removed first. So sorry, 3. First time you run this, you're searching for the first element. It's going to output 20, and then 3 is removed. So then element number 1 will be 10. So 20 and 10 should be 25. And I can remove all these removes because we have a destructor which will do that. So we have a destructor which is going to do these things. Okay. Now let's compile. LL remove has a problem. So there's nothing called as remove. So it has to be just remove from. Right. Now let's compile. Yeah. So it is, yes, it's in the list. Okay. So LL dot search 30. I didn't put not of it. Okay. So it's not good. So it has come. No, it is not there in the list. 30 is not there, and then it has printed 20, and then 10, just like we wanted. Good. So, but as a what do you call, as an ADT, I don't want the user to think whether I am adding in the front or in the back. That's something the user need not know about. So I'm going to add another function. I'll keep that function there, but I'm going to give another opportunity, another function for the user, because he can just add and do an append. Is it append or add? It has to be just add. Okay. That makes sense. So in this case, I just call the addFront. Things are fine. This looks fine.